In this short demo, I will show you how Vitria's Via AIOps can be used to detect devices, specifically access network routers, that have become isolated from the network. I'll also demonstrate how the customer impact of the isolated device can be determined and how the Via AIOps agent framework can be used to determine and implement the best course of action to reduce customer impact, to reduce costs, and to improve the mean time to repair the issue. A cell site router, or CSR, is a key component of a 5G radio access network. It is installed remotely at the cell site base station and aggregates mobile data traffic from the radio access network and transports it back to the service provider's core network. When a CSR becomes isolated, it loses connectivity to the broader network infrastructure. This could be due to a power outage, physical damage, a network failure, or environmental factors, and it results in a loss of service for end customers in the affected area. Due to the loss of connectivity, the CSR is not able to report that it can no longer connect to the network, and therefore the CSR isolation is often not detected in a timely manner by traditional monitoring tools. The first step in tackling this problem is to integrate all the necessary data, and in this example, we will focus on device telemetry data, size logs, and SNMP traps, as well as customer experience events ingested from the CRM system. Leveraging a combination of CMDB enrichment data and auto-discover topology, Via's knowledge plane understands the topological relationships between nodes, a key success factor in implementing this use case. In the Via AIOps Incident Action Center, we can see an example of an isolated access router incident where all the causes and effects of the problem have been correlated into a single incident. Firstly, we can see that the node is operating outside of its nominal operating temperature. We then have several link failures to upstream ORAN components and timing servers, as well as adjacency communication failures to nodes in the aggregation layer of the network where traffic is backhauled to the core network and to the internet. We can also see an escalation in the number of customer complaints for customers using the service in that location. This could be an office building, shopping mall, school, etc. This is where intelligent automation really kicks into gear. The system starts polling the node to check its status in real time. We automatically classify the incident so the fix agent knows immediately what the issue is. Leveraging the knowledge plane, including historical context and generative AI, we accurately determine the most likely fix for the incident. A ticket is generated in the CRM system, in this case Jira, including all relevant information to track the problem. As we now know the cause and likely fix of the problem, remedial actions can be taken to mitigate the impact of the problem and to reduce the remediation time. These include integration to the IVR system to enable auto-deflection of incoming customer complaints, and triaging the ticket to field operations and informing them that a technician should be dispatched to resolve the issue. The outcome of all of this is that the mean time to repair the issue is significantly reduced, and customer complaints requiring care agent responses are proactively deflected, thereby reducing costs and improving customer experience.